Welcome to GMAT Viz YouTube channel. In this video, we will understand how important it is to not assume information which is not provided in the question. So what we'll do is, at first, we will look at the common assumptions students make in GMAT Quant questions, and then we will solve a question to understand the impact of making some assumptions. Let us look at some of the common assumptions that students make while solving quant questions. It is fairly common to assume variables as integers even if it is not given in the question. This is a very common mistake and generally happens in number properties questions, especially with even odd questions. I'll talk about this assumption at length while solving the question in the next slide. Another common thing is to assume numbers as positive integers only and not consider what happens when they are negative. This is a fairly common problem when it comes to exponents and number properties related questions. Now, many students do not consider zero many times. In fact, zero is probably the most important number, and not considering it can lead to multiple errors, including confusion between non-negative versus positive integers, because non-negative integers will include zero and positive integers won't include zero. Zero is non-negative as well as non-positive. So people who do not understand the difference between that and do not end up considering zero can make mistakes. If you do not consider zero, you might end up thinking that every perfect square is positive, which is not the case. Zero square is not a positive number. It is a non-positive, non-negative quantity. Similarly, if you do not consider zero, you can assume that unit digit of 5 to the power x, or for that matter 6 to the power x, is always 5. But if x is equal to 0, it is never 5. Now, this kind of problems especially happen in DS questions. Okay, so if you do not assume or do not consider zero, then it is gonna create issues in some DS questions. Now, another common assumption that students make is that they assume some angles or side based on how the diagram provided with geometry questions look. Okay, for example, it is fairly common to see people like assuming an angle as a right angle just because it looks like a right angle. For example, if you see a diagram like this, there is a tendency that this angle seems like a right angle and they take this angle as 90-degree even if it is not mentioned in the question. So it is very important that you read the question stem properly. If you see a sign like this, then you can assume it to be a right angle, or if it is clearly written that this angle is 90 degrees, then only assume it to be a right angle. Do not just go by the looks of the figure. Okay, so even if you see something like this and it looks like a square, do not assume it to be a square. So focus on what is given in the question and do not assume the values of angles or sides from diagrams. So with that, let's now look at one of the assumptions and let's try to see how we can avoid making such assumptions. Okay, we shared this question in the group today and most of the people marked B as the correct answer. However, the correct answer is choice E. Let us understand what is the trap in this question and why most people, including good students, faltered in this question. So let us look at the question stem and analyze it first. So the question stem asks us, is x plus y even? Now, right after reading this, people draw an inference that it means that we need to consider two cases. Case one is that both x and y are either odd or even. So if after evaluating any statement, we can conclusively say that both x and y are odd or even they are even, then basically we can answer the question as yes conclusively. So all we need to determine is whether they have the same nature. Okay. Now there is a case 2 as well. If x and y are opposite in nature, that means one is even and another is odd. If they're opposite in nature, we can still conclusively answer the question as no. Okay, so most of the students, after analyzing the question stem, try to just focus on evaluating the two statements from the perspective of identifying whether case 1 or case 2 can be determined conclusively from it. So the focus completely shifts to case 1 and case 2 and evaluating the statements. Okay, but what they don't realize is they have just assumed something and missed out on the third case, which is that x and y can be non-integral as well. When we say is x and x plus y even, it is not mentioned that they are integers. Case 1 and case 2 are only applicable if they are integers. If x and y are non-integers. For example, let's say x is 2.4 and y is 3.6. X plus y is still even. Okay, it is still 6. It is even. Okay, but x and y are neither even nor odd, because even or odd only apply for integral numbers. Okay, so those of you who assumed that x and y are integers might miss out on something. Let's see, what did you miss out on? So let us analyze statement 1. It tells us 2xy is even. Now we know that 2 is an even number. So you multiply 2 with any other integer, you will always end up getting an even number. So this statement is not helping us much. All it tells us that xy, the product of these two numbers xy, is an integer. We do not know whether they are individually integers or not, and hence we can safely say that statement 1 alone is not sufficient to answer the question. So if I write down the choices over here, I can safely say that A and B cannot be the right answers. So let's analyze statement 2 now. What does statement 2 say? X square plus y square is even. Now, a lot of you marked B as the correct answer. And the reason you marked B as the correct answer was you thought that this statement is sufficient to answer the question. Now, the mistake that most of you did was you assumed that X is an integer. And since you assumed X is an integer, you actually thought of it like this, that if X square is even, it implies that X is also even. Okay, because the if the base number is even, then any power of the number is going to be even as well. This is true, but this is only true for integers. Okay, this is only true for integers. This is not true for fractional values. So for example, if I take x as 2, x square is 4, which is again even. If I take x as 6, x square is 36, which is even. But this is only possible for the integral values of x. What if I take x as root 2? If I take x as root 2, x square is 2. X square is even, but x root 2 is not even, because root 2 is not even an integer. Okay, so those of you who thought that since we know x square plus y square is even, and x and y will have the same even odd natures, x square and y square, sorry, it has the same even odd nature as x and y, I can very well write x plus y is also even. Okay, so those of you who did this did a blunder only because you assumed that x and y are integers. Okay, so since we do not know it, B is not the correct answer. And if you want, I can just show you a value. Let's take x and y, x square as y square, x square and y square, for example, as 8. Okay, if you take it, 8 plus 8, you will find this is even, it is 16. But root 8 plus root 8, which is x plus y in this case, root 8 plus root 8 is just 2 root 2 plus 2 root 2, which is 4 root 2, and 4 root 2 is not an integer. Okay, so B is not the right answer. Statement 2 alone is not sufficient. Now what about both the statements combined together? Let's look at that too. Okay, now let's combine the information in both the statements and let's see what happens. If I combine the information in both statements, I can write x square plus y square plus 2xy is definitely even, because both of them are even. Okay, this is even and this is also even. On further simplification, I can say that x plus y whole square is also even. Okay, but does this imply that x plus y is also even? Can I say that? No. Why not? Because I don't know if x plus y is an integer as well. Okay, if x plus y is an integer, then I can say it, but I don't know whether x and y are integers or not. I don't know whether x plus y is integer or not, so I cannot come to this conclusion. If you just fit this values of x and y, like just the values that I told you earlier, which is x square uh, is equal to y square is equal to 8, which means x is equal to y equal to 2 root 2, you will see that x plus y whole square is coming out as even, but x plus y is just coming out as 4 root 2, which is not a even number. Okay, which is not the even number. So even I'm combining both the statements together, We cannot find the answer, so even C is not the answer, which leaves us with the answer as E. So both the statement combined together are not sufficient to answer the question. Okay, so hope this solution was helpful. What I want you to do is make sure that when you're solving questions, you are not assuming anything at all. Okay, so remember about those assumptions that I talked and make sure that you're not assuming anything. All the best.